My name is Thomas Pierrot. I'm a staff research scientist at InstaDeep. I'm based in New York City. I'm leading the team at InstaDeep that's developing our foundational models for genomics. There are obviously many challenges, but maybe to start with one type of challenge is that you see when you need to train these models at scale, you need to switch on a lot of machines at the same time, a lot of GPUs. Sometimes these GPUs, we have, for instance, 8 GPUs on the same machine. And so if you want to launch a very big training with hundreds of GPUs, you're going to launch dozens of machines. And then you're going to need to know how to parallelize or to distribute the compute you need to train your neural nets. And being able to run that on all the GPUs you have. And something that happens very often, for instance, is that one GPU out of the hundreds you have can have a failure, right? And so your whole run can crash because of that. And so a very common challenge is what sometimes we call run babysitting, which is you need to have someone constantly watching the run so that in case of a crash, you can relaunch the run, for instance. Another challenge is that these neural nets, when they are very big, can be also unstable when you train them. So unstable in the sense that when you train a neural network, you monitor something called the loss function, and you expect the loss function to decrease over time. And for very big neural networks, sometimes you observe that this loss function can spike. So you can suddenly come back and start forgetting what you've learned. When this happens, a technique is also to restart the run. So to detect that early enough and to being able to come back and relaunch the run from the previous checkpoint. And for both these issues, AIchor can be very useful because it makes it first easier to monitor the run and so to detect these problems, but it makes it also easier to relaunch the experiment when you need to do it. I think it helped a lot with our productivity. Mainly because people can spend more time designing the experiments rather than spending the time launching them. And also because I observed that now the engineers in the team really don't mind launching much more experiments, trying much more assumptions than before because they don't have these technical challenges that they had before. So I really realized that during the summer when we started to use every AIchor, we gained a lot in productivity in many fronts because our engineers started to try experiments they wouldn't try before. That they became much more audacious and it really boosted up the productivity of the whole team. What's amazing with AIchor is that you don't need to redo the setup every time. It's completely abstracted for you. You just need to define once the Docker image you want to run and once the type of workflow you want to run. And then within a single command line, you can switch a machine with whatever the number of resources you need, launch this experiment, and also even track this experiment from the AIchor UI. Whereas before, for instance, you need to track each experiment separately, or you need to write your own software to be able to do that. And so in our team, it really changed a lot the life of the researcher because instead of spending a lot of time on having to set up of this experiment themselves, they can more focus on what are the experiments they want to launch and then basically just launch a few command lines, even a single command line, and get all of that launched at the same time. So day to day, mainly because they gain time. They don't have to do all of this work of finding the machine, setting the machine up. So they gain a lot of time. They can then use this time to focus on more important aspects. Also because I realized that before, because of all of the work that was required to start a new experiment, sometimes a member of the team would not start an experiment just because they knew that it would take them too much time. Now they really don't care about that anymore, and they are really going to launch the experiments that they think are important just because they know that it's very easy to do it. An example is that if you want to train an AI model and you want to try, 5 different parameters, before you had to repeat 5 times the same workflow of like finding the machine, setting up the machine. And so what could happen is that in the end, member of the teams would try only 3 parameters out of the 5 because it was too much work. Whereas when using AIchor, if you have the compute available, it's not much more work to do it. And so I see that member in the teams in the end run much more experiments and try much more things, in the end are much more efficient just because it's easier for them to do it. What's great with AIchor is that it's independent of what you want to do, right? You want to launch any experiment that involves running code. It can be training an AI model, it can be cleaning data. We use also AIchor a lot for data cleaning, for data processing, for all sorts of things. Anytime you want to run some Python code that needs a large amount of resources and a lot of setup, AIchor is going to take care of that for you. And so in our team, we use it obviously to train models, but we use it for everything. Basically, every time we need to switch on a large machine with GPUs or even without GPUs, we use AIchor in our workflows. So the biggest advantage of AIchor in our research is to gain time. Is not to have to worry about like doing of these phases of like finding the machine, but really being able to focus on what are the right experiments to launch, and also on all the aspects around experiment tracking. Because previously it could be even sometimes hard to like find where the experiments are if you're unsure, how to find which ones are working, which ones are not working. Whereas when with AIchor, you have a unified interface where you see all of your experiments at once. Even for me, I can see all of the experiments of the team and very easily focus on what matters and just focus on launching all the experiments you need and tracking them. You don't have to worry about like finding the machine, starting the machine, setting up the environment in the machine. You just have to worry about what it is you want to launch, and then you just press a button and it does all of this work for you. In the US right now, there's a lot of capital being invested, and so there are a huge amount of startup and research team starting having access now to very large number of GPUs. I think AIchor is as useful in the US or outside the US, but just that there are more people in the US who are going to be in this setup where they have actually hundreds of GPUs, where they can actually run hundreds of experiments, where they can try all the assumptions they would like. And so AIchor for them is really going to accelerate them in doing that.